Assalamualaikum and hi everyone. In this video, we're going to learn about emitter bias unbypass for BJT small signal analysis. Before I proceed with this presentation, I hope you have better understanding on Ohm's law, KVL, and BJT DC biasing. Okay, this is this configuration for the emitter bias unbypass. The difference between unbypass and bypass is the capacitor here. There is no capacitor to bypass RE. So that's why the signal have go through the RE. Okay, for the equivalent circuits, okay, I hope you remember this transistor equivalent circuit. And then from the base terminal, it will connect to the RB, and then from the RB is connect to the ground. This one is represent here, which is from the base terminal go to RB and then go to VCC. VCC actually we need to ground it. Same goes to here. It should be ground here. So is the input. We measure the input here. Okay, and then for the R node, and then for the output side, which is from the terminal. C terminal we connect to RC and then go straight to the ground. This one is represent here, okay, from the C terminal to the RC and then to the ground. Okay, but for the E terminal is different with the previous configuration where the E terminal will connect to the RE and then from the RE connect to the ground. So meaning that the input and output side is share the same resistor here, which is RE. And then for this analysis, we're going to ignore the R node because R node is usually is very big or extremely big. So we can say that R node nearly equal to infinity. So it's going to be open circuit here. So this is the circuit, the full equivalent circuit. But for the analysis, we're going to use the easier equivalent circuit where the input and output side we treat it independently. Okay, how to use this circuit? First, we need to make a to calculate a new RE. Okay, to calculate the new RE, why we need to calculate the new RE? Because for the input current here, it's represented by IB, but here the current is IE. So that's why we need to get the new value of RE in terms of IB. So okay, to find the value of new RE, so what we need to do is have to find the voltage here. Let's label this one for the VE, and then by using the Ohm's law, we can find the new RE. Okay, let's label this one as a RE prime. So RE prime is equal to VE over, okay, the corresponding current is IB, so we have to divide by IB. So the VE is equal to the current here is IE, so IE times with the RE over IB, and then just substitute or represent the IE in terms of IB. So this is the representation. So beta plus 1 IB times with RE over IB. So you're going to have the value of beta plus 1 times with RE. So to make our analysis easier, we're going to do to make some assumption which is beta plus 1 nearly equal to beta. So you're going to have the beta times RE. So that's why the new RE is equal to beta RE. So you can use the previous techniques to find the value of Zin. So the value of Zin, if you look from left to the right, you can find it. This resistor is parallel with this resistor. Okay, this resistor usually we represent as a ZB. Okay, the value of ZB is equal to beta RE plus beta RE, capital letter. Okay, so just simplify this representation. So beta RE times RE plus RE. So Zin is equal to RB parallel with ZB. Okay, this is the input impedance. So for the output impedance, it's very clear that we only have the RC. There is no another resistor here. So Z0 is equal to RC. So, so for the voltage gain, the equation for voltage gain is AV equal to V0 over Vin. Okay, for the Vin, find the Vin. Vin is parallel with this voltage and also this voltage. But for this voltage, we cannot find the value because of we do not have the information of I or the current. So what we're going to do is we have to use this voltage where the value of current is given IB, and also we have all the information regarding the resistor. So Vin is equal to IB times with the total impedance that we represent in terms of ZB just now. So IB times with beta RE plus RE. Okay, for the Z node, the current flow from top to down of at the RC from the down or for the bottom to the top. So it's going to be plus minus. So because of the different polarity here, so your V node is equal to minus. Okay, so the total current is beta IB, and then the total impedance is RC. So just substitute the value here, and then I have the beta IB here times with the RC over IB times with beta RE plus RE. Okay, just cancel out the beta and also IB. So you're going to have the value of voltage gain equal to RC over RE plus RE. Okay, this is the voltage gain. And then this is the phase relationship. Actually, this is almost similar with the previous one, which is the relationship is inverted, or I can say the phase relationship is 180 degrees difference. So what next? I hope you do a lot of example in electronic device and circuit theory. And this was my next video on voltage divider bias configuration unbypass. That's all. Thank you for listening.